Hey guys, we're back with the notes for 9.4. Today we're going to be simplifying, multiplying, dividing, adding, and subtracting rational expressions. I'm going to do this in 3 videos to try and make it as short and sweet as possible. So this video is just going to be about simplifying, okay? All right, we are actually only going to do 3 of these problems, so hopefully this will be a pretty quick video. Rational expression is anything where the numerator and the denominator are both polynomials. So something with like an x squared minus 16, something with a 2x minus 1, anything like that where you have a polynomial on top and bottom. Okay? Rational function isn't on this page. That means it's a function written as a rational expression. That would be something I'm asking you to graph or something I'm asking you to solve. Okay? All right, so let's scroll down just a little bit. We are not going to do problem C. So you can just go ahead and cross him off. But I've written out your steps. Okay, so the steps are going to be number 1, factor the top and bottom completely, so break it all the way apart as simple as it can. Number 2 is going to be look for if you have the same factor on the top and bottom so they can cancel. And number 3 would be to put any pieces that you need to FOIL back together or any GCFs that you've pulled out, distribute them back together. So you want your answer to be simplified with no parentheses. Okay? All right, let's go ahead and get started on the first one. So the way I like to do it might not be the way that's easiest for you. The way I like to do it is to kind of take this piece and factor it above it, take this piece and factor below it, and then kind of cancel it. It makes sure that I can save a little bit of space. I'm going to do the first one like that, but the rest of them, I'm going to go ahead and write out each individual step, okay? So for this first one, if I'm going to break x squared minus 16, I notice that's a difference of squares. Okay, so I can break it into x and x. I know that 16 is a square, so 4 and 4. That means I'm going to have an x plus 4 and an x minus 4. That top is completely simplified. So you could write it above it, or you could say that is my second piece. Okay. For the second one, I'm looking for numbers that multiply to make 28, add up to make an 11. I have an x in front, so I can go x and x. 4 and 7 are the ones that stand out to me, and everything in this problem is positive. Okay, so again, you could write them above it, like this. I like to do that, or you can write it off to the side as like a separate step. Okay, that's step 1. Step 2 is going to be to cancel out any factors that are the same on top and bottom. So if I do that, I have an x plus 4 and an x plus 4. One's on top, one's on bottom. So I can eliminate those. When I write my answer, all I'm doing is writing the pieces that are left, so x minus 4. There's nothing else to distribute, nothing to multiply it with, so I don't need parentheses anymore. My answer, x minus 4 over x plus 7 on the bottom, I don't need parentheses anymore. This is a final answer. Okay? If you need to pause it, copy that down, go ahead. We're moving on to B. All right, so for B, first thing I notice is that my top is kind of in a weird order. So I'm going to order this so that the x squareds are in front to make my life a little bit easier. So the first step I'm going to reorder, negative 2x squared plus 5x plus 12 over the bottom, 2x squared minus 3x minus 20. Okay, looking at the top, this is not easy to factor because I have this little nagging negative out front. Okay, so my first step is going to be to pull a GCF out. So I'm going to kind of do a circle to tell you what I did. I'm taking out a GCF of a negative 1. Okay, so I'm going to take negative 1, factor it out. So I have a positive 2x squared, a negative 5x, and a negative 12. And on the bottom, I'm keeping exactly what I had, 2x squared minus 3x minus 20. All right, now I'm finally ready to break it apart and actually start factoring it into something I can use, okay? All right, if you were doing the top, you would want to swing and divide. So 2 swings over to the negative 20, or sorry, to the negative 12, making negative 24. If I'm looking for numbers that would multiply to make 24, but would also add up to a negative 5, I'm thinking 8 and 3. All right, so I need the 2x and an x. I need the 8 to come from 2 times 4. I need the 5 to come from, or sorry, the 3 to come from just a 3. And if I was going to do this all the way out, I guess you guys usually see it all the way out, sorry. So I just swing, x squared minus 5x minus 24, break it into x minus 8, x plus 3, pull back out that 2, so x minus 4, swing that 2 back out, 2x plus 3. Okay, so that's where I'm going with it. All right, so my top is factored. Let's do the same thing on bottom. So I'll do my swing and divide, and then I'll erase it so you can see it. All right, I'm going to swing, x squared minus 3x minus 40. All right, I'm multiplying to make a 40, adding up to make a 3, so that looks to me like an 8 and a 5. So x minus 8, x plus 5. I swung a 2, so I have to pull that back out. Whoops. Divide out the 2. That's x minus 4. Swing that 2 back in, 2x plus 5. So those are the pieces I'm going to use, x minus 4 and 2x plus 5. All right, both top and bottom are now factored completely. We're looking to see if there's the same pieces on the top and the bottom, and there are. X minus 4 is on the top and the bottom. I'm going to eliminate him. Now, when I put everything back together, I cannot leave this 1 chilling on the outside. I'm going to have to distribute him back in. So when I write my answer, I'm going to go negative 2x minus 3. I just distributed the 1 back in here. Okay. On the bottom, I don't need parentheses. I don't have anything left to multiply with the 2x plus 5, so he just stays out of parentheses. All right, B is completely done. We have one more. Perfect. Moving down to D. D, I'm looking at this. There's only 2 pieces. So I'm looking. I notice there's a GCF in the top. Both of those pieces can be divided by a 2. Both of those pieces have an x, and both of them can give an x squared. So if I pull 2x squared out of that, I still have a 4x, and I still have a plus 1. So that's my top row. On the bottom, I notice both of them have a negative I can take out. Both of them can give an x, but this guy doesn't have any number to divide out. So if I pull this down, I'm keeping a 4, keeping an x, and then I took everything from the other guy, so all he has is a plus 1. I get lucky that those are exactly the same, so the top and the bottom are going to cancel. All I have left in this problem then, if I'm looking at 2x squared, I want you guys to know that that's really the same as saying 2 times x. And on the bottom, I have negative x. So I kind of get lucky that there's that there's another thing I can cancel off. I can cancel off these x's too. All right. So we would never write a problem as 2x over negative 1. Okay. That's actually just going to be a whole number. So if I say 2x divided by negative 1, it's really just like saying negative 2x. And this is my answer. Okay. All right, I'm going to zoom out. If you missed anything on the screen, feel free to go ahead and copy it. Otherwise, we are done with our simplified video.